Solving linear systems by graphing. Here we go. This is the beginning of chapter 7. We're going to mix a little 6 in as well, but basically this is what it's about. All right. How do you solve systems or linear equations by graphing? And I'll tell you what a system is in just a moment. I do want you to take a minute to graph the equation. Notice that x and y are on the same side in standard form. The most efficient way to graph this is using a baby table. So use a baby table. Okay, so this is what you should have gotten. When you plug in 0 for y and solve for x, you get -1/2. When you plug in 0 for x, then y is equal to 1, and you just plot those points. All right, so here we go. A system of equations. It consists of 2 or more linear equations in the same variables. So for example, you might be given something like this. Notice that it's 2 equations with the same variables. It's a system. Okay, there you go. That's it. An ordered pair, so the solution to this system. Let's talk about a solution to that system. It's an ordered pair that makes both equations true. It has to be the point where their lines intersect. So I'm just going to try and make a quick sketch here of what these 2 lines would be like. It's not exactly accurate, but they would look something like this. And maybe something like that. So this ordered pair here, I'm going to say is 3, 2. It is the point of intersection, and if it is the solution, which it should be, it would make this equation true by plugging in the x and the y, and it would make this equation true. It would make this side equal 5, and this would make this side equal 7. So that is a solution. Okay, graphing is only one way to solve a system. One of a few that we're going to look at in this chapter. It's the most inaccurate because it's really hard to find the exact point of intersection, but it's still a method for solving. Solving a system of equations using the graph and check method. So here's the steps, and I want you to follow the steps. If you follow the steps, you'll be on your way. So the first thing you do is you carefully graph both lines using a ruler or a straight edge. It's important that you have straight lines so you can find the most accurate point of intersection. When you're graphing, you should use the most efficient method for graphing. For example, there's 3 methods that we worked with in the last chapter. The first one was slope-intercept. So if it's in slope-intercept form, you can easily graph by using the slope and the intercept. The second one is point-slope. And if it's in point-slope form, you could pull out the slope and a point and graph it that way. Or a baby table if it's in standard form. Because you really only need 2 points to graph. Okay, so choose the most efficient way for graphing and then graph it that way. Once you have the 2 lines graphed, then you find the point of intersection. And that should be the solution. Step 3, you plug the point into both equations to make sure the left side equals the right side. Let's use this example from above. So for these 2 lines, I've said that the point of intersection was 3, 2. Let's test to see if it really is a solution. So I'm going to plug in 3, 2 to my first equation. So the x is 3 plus 2 times the y, which is 2. That's my x, that's my y. Does that equal 7? Okay, 3 plus 4 equals 7, 7 equals 7. Yes, it's true for this equation. The left side equals the right side. Let's try it for the next equation. Okay, so 3 times 3 minus 2 times 2, does that equal 5? 9 minus 4 equals 5. Yes, 5 equals 5. So it's true for that one too. So that means that 3, 2 is the solution for the system. Ready? Let's try some of these then. Okay, solve the linear system by graphing and check your solution. You should get a ruler. a ruler. So he's going to have straight lines, or some sort of straight edge if you don't have a ruler. Okay? So the first thing we need to do is graph these two equations. So I'm going to start with the first one, 5x plus y equals 10. It's in standard form, x and y on the same side. The most efficient way is to use a baby table. So I'm going to plug in 0 for y and 0 for x and see what I get. When I plug in 0 for y, the y goes away. Divide both sides by 5, x is 2. When I plug in 0 for x, that goes away, and y equals 10. So I'm going to plot those 2 points. Over 2 up 0 is right here. Over 0 up 10 is right here. And I'm going to connect them with as straight a line as possible right through the center of those points that you drew. Okay, there's the first line. Then I'm going to do the next one, negative 5x plus y equals 0. Now I'm going to show you something that you've not seen before. Sometimes when you use a baby table, there's a problem. Look what happens. When I plug in 0 for y, that goes away. And then I divide both sides by negative 5, and I get 0. Ooh, that's not going to help me graph this line. If I plug in 0 for x, I also get y equals 0. This is a problem. Uh-oh. Can't do it this way. Okay? So if you get this, that means you've got to try a different method of graphing. So what I'm going to do is I'm going to move this into y equals mx plus b by adding 5x to both sides. Oh, and look at that. Now I have slope-intercept form. This is telling me I start at 0, and I use my slope to get my second point. So up 5, 1, 2, 3, 4, 5, and over 1. Here's my 2 points. I started at 0 because that's 0, and then I went up 5 over 1. Remember, it's rise over run. So then I connect those two, and I can see that the point of intersection right here is 1, 5. So let's see if that's the solution. So I'm going to write that down here, 1, 5, x, y. I'm going to plug it into both of my equations to see if it makes them both true. So my first equation would be 5 times my x plus my y. Does that equal 10? 5 plus 5 equals 10, and 10 equals 10. So it makes the first one true. Yes. Let's try the second one. Negative 5 times 1 plus 5, does that equal 0? Negative 5 plus 5 and 0 equals 0. Yes. So that means that 1, 5 is the solution to my system. Okay? All right, let's try another one. So I have 2 equations here that I need to graph. So I'm going to start with this first one. Negative x plus 2y equals 3. X and y. Okay, so this has x and the y on the same side, so I'm going to make a baby table. 0, 0. Plug in 0 for y, and I have negative x equals 3, which means I have to divide both sides by negative 1. 3 divided by negative 1 is negative 3. If I make x 0, I'm dividing both sides by 2, and I get 3 halves. Okay, so I can go ahead and plot that one. Negative 3, 0. Over 0, this is the same as 1 1/2. So over 0, up 1 1/2, and I'm going to connect those. All right, now my other equation happens to be in slope-intercept. See, y equals mx plus b. So this is my intercept, so I'm going to start at 4. 1, 2, 3, 4. My slope is negative 2 over 1. So I go down 2 over 1, and I can go ahead and connect those. And I have a pretty clear point of intersection here. It's over 1 up 2. 1, 2. So let's see if that makes both of those equations true. Okay, so my solution I'm saying is 1, 2. This is x, this is y. Let's plug it in. So negative 1, I'm plugging it into this equation. Negative 1 plus 2 times 2, does that equal 3? Negative 1 plus 4 equals 3. And yes, 3 equals 3. Then I plug it into the second equation as well. So I'm going to plug it into y equals negative 2x. So y is 2 times negative 2 times 1 plus 4. 2 equals negative 2 plus 4. 2 equals 2. Yes, it does work. Okay? All right, I don't think we're going to need to do this one. We can. We'll do it real quick. So these are both in standard form. Easiest to make a baby table. And it does work. Plug in 0 for y, you're going to get 5 for x. Plug in 0 for x, you're going to get negative 5 for y. And then 3x plus y equals 3. I'm just kind of doing this sort of fast because it's really the same as the other two. If you plugged in 0 for y, you're going to get 1 for x. If you plug in 0 for x, you're going to get 3 for y. So I'm going to go ahead and graph those. Alrighty. Over 5, up 0, 1, 2, 3, 4, 5. Over 0, down 5, 1, 2, 3, 4, 5. I'm going to connect those with my ruler. And then for this one, I'm going to go over 1, up 0. Over 0, up 3. And I'm going to connect those as straight as I can. And it looks like the solution is right here, over 2, down 3. 2, negative 3. And when you do plug that one in, it does work. So 2, negative 3 is the solution. Okay? All right. The cost to join an art museum is $60. If you are a member, you can take lessons at the museum for $2 each. If you are not a member, the lessons cost $6 each. Write a system of equations. That means I need 2 equations that can be used to find the number x of lessons after which the total cost y of lessons with a membership is the same as the total cost of lessons without a membership. So I'm just going to write down here what they say x is. X is the number of lessons, and y is total cost. Now, since I have to write a system, I need 2 equations. So I'm going to start with the first ones for the members. If you're a member, your cost is equal to the $60 fee plus $2 for each lesson. If you're not a member, this is if you're a member. If you're a non-member, you don't pay the $60 fee. Okay? If you're a non-member, you just pay $6 for each lesson. So your cost would be 6x. Now you want to know after how many lessons is the cost equal? Okay, so I want to know when this is equal to this. So I want to know when 60 plus 2x is equal to 6x. Because this is what it costs to be a member. This is what a non-member cost is. So I subtract 2x from both sides. I'm going to run out of room here. I apologize. So I'm going to go up here. And I have 60 equals 4x. X equals 15. So after 15 lessons, the cost is the same. Okay? This one It says your school is selling football tickets for a home game. The school sold 35 tickets for $86 on the first day of the sale. Student tickets cost $2 each and non-student tickets cost $3 each. Find the number of student tickets and the number of non-student tickets the gym sold. We're going to use a graphing calculator. I'm going to show you that in class, okay?